Let's look at section 5.3 right now. What I'll be doing is, like I've been doing in the past, I'll go through and list all the theorems and basically give you an outline of all the proofs and work a few examples. This is a pretty long section. Um, so if you were to write down all the steps on all the proofs, it would take you quite a while. So, whoops, let's get started. Theorem 514. A diagonal of a parallelogram forms two congruent lines. Okay, so let's draw a diagonal here. Form two congruent triangles, sorry. Okay, and we have two triangles. Now this is a parallelogram, remember? Okay, so what we know is that because BC and AD are parallel, AC is a transversal that's crossing those two lines. So angle BCA is congruent to angle DAC, excuse me, angle DAC, angle BCA is congruent to angle DAC because they are alternate interior angles formed when a transversal crosses two parallel lines. Okay, BA and CD are parallel. AC is a transversal. When it crosses those two parallel lines, it forms alternate interior angles there. So angle BAC is congruent to angle DCA because two parallel lines are crossed by a transversal and alternate interior angles are congruent. Now, AC, that line is congruent to itself. So let's think of it as CA. Okay, so this side's congruent to itself, and what you have is angle, side, angle. Triangle DCA is congruent to triangle DAC by angle, side, angle. Okay, and there's nothing special about the diagonal I chose here. If you chose the other diagonal, then you'd get the two triangles that were congruent, it would be BAD and CBD for the very same reasons. Okay, some nice little corollaries here. Here in a parallelogram, the opposite sides are congruent and the opposite angles are congruent. Well, just look at this previous picture. You got a parallelogram, draw your diagonal, you have congruent triangles, so this side and this side correspond, they're going to be congruent. This side and this side correspond, they're going to be congruent. Okay, so that's your opposite sides are congruent. And opposite angles, well, this angle and this angle correspond, so they're going to be congruent. If you draw the other diagonal BD, you'll get a big angle here at A. If you draw the other diagonal, you get a big angle at A congruent to the big angle at C. Okay, because of the other sets of congruent triangles. Okay, now corollary 516. Parallel lines are everywhere equidistant. Okay, so let me draw a couple of parallel lines. Here's one and here's another. Now, when you're talking about distance between lines or distance from a point to a line, you're talking about perpendiculars. So what we're trying to show is if I have two parallel lines, call them L and M, okay, I want to show that a perpendicular from L to M, and if I draw a perpendicular here from L to M and another one over here, they're the same length. Those are supposed to be perpendicular. Okay. Well, what do we know here? We've got but we know that if we have two lines that are perpendicular to a third, these two guys are going to be parallel. Okay. And so what I have formed here in the middle is, well, it's a rectangle, but that's not really what I'm after. It's a parallelogram. And since it's a parallelogram, opposite sides are congruent. So that's why corollary 516 is actually the corollary of 515. It follows very quickly from 515. Let's mark a homework type problem here. Number 15 from the end of the section. Find the measures of the numbered angles in parallelogram ABCD. And some of these are really pretty easy. Let's see. First thing, what do we know about here? We've got a right triangle. Maybe I should give this a name here. Right triangle BEA. Oops. Give a few more names. ABCD. I think I got every done here. Right triangle BEF. So that tells us that the measure of angle 1 is 90 degrees minus the measure here. So it's 35 degrees. Okay, there's angle 1. Okay, now what we just had, previous, I think 515, said that in a parallelogram opposite angles are congruent. So that says that this angle is, if this is 115, then this big angle is 115. So the measure of angle 2 plus the measure of angle 1 is 115 degrees. So the measure of angle 2 is 115 minus 35 degrees, which is 80 degrees. Okay, so I've got that. And 3 is pretty easy too, because we had a corollary. If you have 2 parallel lines cut by a transversal, then interior angles on the same side of the transversal are supplementary. So the measure of angle 3 plus 55 degrees has to be 180 degrees. So the measure of angle 3, 180 minus 55. So this is 125 degrees, right? Yeah, 125 degrees. Okay, so 35 for 1, 80 for 2, 125 for 3. Okay, next we're looking at the theorem 517. Both pairs of opposite sides of a quadrilateral are congruent. The quadrilateral is a parallelogram. Okay, so this is a corollary to part of 515. So we know that BA and CD are congruent, and we know that BC and AD are congruent. I want to show I have a parallelogram. Well, draw a diagonal. Okay. Now what do we have? We have then that, of course, these opposite sides are congruent, those are congruent. AC is certainly congruent to AC. So by side, 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 okay, triangle ABC is congruent to triangle CD, triangle CDA. And if those triangles are congruent, then so angle BCA is congruent to angle B and D corresponds to DAC. So this angle and that angle are congruent, and that means BC is parallel to AD. And also by side, 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 I know that, well, the triangle, I know the corresponding parts, this angle and that angle are congruent. Angle BAC congruent to angle DCA. And so that gives me that AB is parallel to CD. Because when the alternate interior angles are congruent, the sides, the lines are parallel. So 517, pretty quick little thing here. 18. If both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Well, this one I'm not going to do a little differently. Okay. So I'm going to put little X's there because angle A and angle C are congruent, so that's going to be the measure. Okay. And I'm going to put little Y's here because angle B and angle D are congruent, so I'll call them those measures Y's. And what we know, because this is a quadrilateral, we know that this is a quadrilateral, so you take the number of sides, 4 minus 2 times 180, and that gives you the sum of the angles. So 2x plus 2y, 360 degrees, so divide by 2. X plus y is 180 degrees. And somewhere along the line we had, I think it's corollary 5.4, that's going to, we have two lines cut by a transversal so that the interior angles on the same side of the transversal are supplementary. That means the lines are parallel. So this means that BC is parallel to AD. And if you think about X plus Y this way, you also get that AB is parallel to DC. 519. Quadrilateral. If a quadrilateral has two sides that are parallel and congruent, then it's a parallelogram. Okay. So let's say the sides are BC and DC. Okay. So these, excuse me, not BC and DC. What am I thinking here? AB and I want AB is parallel to DC. So I want AB is congruent. So I want these two sides. Draw a diagonal. And it doesn't matter which one. I'm going to draw this one here. Now, because AB and DC are congruent, I know that this side, this angle, and this angle, because they're alternate interior angles, so they're congruent. So angle ABD is congruent to angle CDB. And of course, BD is congruent to itself. I'm going to think of it the other way around, DB, because that's reflexive property. So I have side, angle, side. Okay, so this gives me the triangle ABD is congruent to triangle ABD, CDB. And what that tells me then is that these sides are congruent. Therefore, hence BC is congruent to AD. Oops. Okay, and if both pairs of opposite sides of a quadrilateral are congruent, the quadrilateral is a parallelogram. A 517. There we are. Okay, 20. The diagonals of a parallelogram bisect each other. Let E be the place where the diagonals intersect. As shown. Okay, this is a parallelogram. So I know that this angle and this angle are congruent. Okay. So we know that angle CBE, and I'm not going to go all the way to D here, is congruent to angle ADE. Let's see. And we also know there's so many different ways of doing this, that this angle and that angle are congruent. Angle DAE is congruent to angle BCE. Okay. Since this is a parallelogram, I know that opposite sides are congruent as well. That AD is congruent to BC. So what I have here are two angles and an included side of one triangle are congruent to two angles and an included side of another one. Then triangle BEC is congruent to triangle DEA. Okay. And what that tells us then is that BE, because of corresponding parts, is congruent to DE, and AE is congruent to CE. So they bisect each other. 521 is converse of this. If the diagonals bisect each other, then it's a parallelogram. Okay, so again, let me put my little point. Let's see, let's give me a little extra space here. And let me put a little point here. Okay. If the diagonals bisect each other, okay, bisect each other means that BE is congruent to DE. So those two are congruent. It also means that CE is congruent to AE. So those two are congruent. Plus, we have, when two lines are intersect, the vertical angles formed are congruent. So angle BEC is congruent to angle DEC. These two guys are congruent because they are vertical angles. Now I have a side, two sides, and an included angle of one triangle are congruent to two sides of included angle of the other. So by side angle side, triangle BEC is congruent to triangle DEA. And depending upon how you want to do it, that tells us that these two sides are equal in length. BC is congruent to AD. Now similarly, we have some vertical angles here and here, which means that BEA and CED are congruent, which forces those opposite sides. And the way mathematicians say it is they say by a similar argument, because they don't like to write it down anymore. AB is congruent to CD. So if opposite sides are congruent, okay, if opposite sides are congruent, we have a parallelogram, 517. Okay, a rhombus. Let's make sure we understand rhombus. A rhombus is a quadrilateral where all four sides are congruent. Okay, so probably the easiest theorem in this section is theorem 522. Every rhombus is a parallelogram. Well, it's a quadrilateral. Okay. And I know that those opposite sides are congruent. Each pair of opposite sides is supposed to stay congruent. You can't do it. Why? Because they're all congruent. If you have a quadrilateral where pairs of opposite sides are congruent, you got a parallelogram. Okay, 23. Diagonals of a rhombus are perpendicular to each other. Okay, we've got a rhombus. So I know that AB and CD are congruent, BC and AD are congruent. Everything's congruent at each other sidewise. Okay. We also know, so let's write this down. AB is congruent to AD, and I know that okay. Now, a rhombus is, we just said, it's a parallelogram. Okay. So that means that what we learned before about parallelograms is that the diagonals bisect each other. So BE is congruent to DE. Okay, so this distance and this distance are the same. Okay. Well, I have some triangles here on top. Okay. I have now the triangle AEB has to be congruent to triangle AED because of side, side, side. Okay. Because these two triangles are congruent, the corresponding parts are congruent. Angle AEB is congruent to angle AED. Okay. Also, since this forms a straight angle here, I mean, since BED is all in one line, the measure of angle B, yeah, the measure of angle AEB plus the measure of angle AED better be 180 degrees, but these are the same. Right. So this is 2 times the measure of angle AEB, because these two angles are the same measure. So the measure of angle AEB is 90 degrees. So this is 90, which means that's 90, which means everything in here is 90. So everything's perpendicular. 524. So let's do a converse here. If the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. Okay, so we have a parallelogram. And there's a whole lot going on with parallelograms here. So we have a parallelogram and perpendicular diagonals. What we want to show is that all those sides are the same length. Okay, so what we know about the parallelogram is that if you got a parallelogram, among other things, the diagonals bisect each other. Okay, so those two are the same, those two are the same, because it's a parallelogram. Perpendicular means I've got right angles. At E. So this is a right angle, this is a right angle. Well, so I've got right triangles here. So triangle AEB is congruent to triangle AED by left leg. Okay. Or side angle side, same thing. Okay, so from that I have that AB has to be congruent to AD because they're corresponding parts. Okay. Well, look at the triangle over here as well. Triangle CED and AED have to be congruent. Again, by leg to leg, so CD has to be congruent to, oh, we can, actually, I don't have to do this. I'm getting carried, I'm putting in some unnecessary stuff. It is a parallelogram. So that means opposite sides are congruent. So these two are congruent, those two are congruent, and of course those two we just showed, so all the sides are congruent. Rhombus. Now, of course, if you're writing this down in a two-column proof or something, you've got to put in some more detail, but I've talked my way through this. Okay. Now, you're not going to find the next theorem in the book. It's kind of a corollary, whatever. It's just kind of putting all these things together. So I called it 524.5. Since this is where it would fit if you were doing this, it says if the diagonals of just a quadrilateral are perpendicular bisectors of each other, the quadrilateral is a rhombus. So if you want to make a rhombus, make some perpendicular bisectors. Okay. This is a quick little application here. We know that the diagonals, we've got a quadrilateral here, the diagonals are perpendicular bisectors, so I know that those two are the same. The bisectors is those two are the same. I know perpendicular, and so by the same reason, okay. This side and this side have to be the same. This and this side have to be the same because of leg, and this side and this side have to be the same. So all the sides are the same. Okay, now we've got an if and only if theorem here. A parallelogram is a rhombus if and only if its diagonals bisect the opposite angles. Okay, so I'm going to do this in two parts. One of the parts is actually this is the if part. Parallelogram and diagonals bisect. And that implies rhombus. I'm going to do this here. So if its diagonals bisect, then you've got a rhombus. And the other direction is if your parallelogram is a rhombus then diagonals bisect opposite angles. This is actually the only if part. Kind of hard to understand it sometimes, but so that's why I didn't make a big deal out of it in topic 1. Which direction is if and which direction is only if, which one is necessary, which one is sufficient. That's a little hard to see sometimes because of the way we write it. Okay, the first part. This is the if direction. We're going to start with a parallelogram, and the diagonals bisect the opposite angles. Okay, so what this means is, so angle BAC, excuse me, let's put my little E here. I'm going to need that. Let's not call it C, let's call it E. Let E be where they intersect. Angle BAE is going to be congruent to angle DAE. Okay. So those two are bisected. Okay. We know it is a parallelogram. So I know that angle BAE is congruent to angle DAE because these are parallel lines cut by a transversal. I also know that angle DAE I didn't say something wrong, I just wrote the wrong thing down here. That BAE is congruent to angle DCE, and then angle DAE is congruent to angle BCE. Okay. Those all have to do with parallel lines cut by a transversal. Okay, I might be writing more stuff down than I actually need here. This is theorem 5. And we know if I have parallel lines cut by a transversal here that, and the diagonals bisect, so that angle and that angle are the same. So angle ABE is congruent to angle CBE, and ABE is congruent to CDE, and so because two parallel lines cut by transversal, and I also know that angle ADE is congruent to angle CDE. ACBE. Try that again. So this angle and this angle. Well, what do we know here? So it's a parallelogram. Okay, now what else do we know about parallelograms? Diagonals bisect each other. So this side and this side are the same. This side and this side are the same. Okay, and we've got a whole lot going on here. We've got all kinds of angle, side stuff going on. So we get that triangle B, what am I looking at? EA is congruent to triangle DE. And this is actually angle, angle, side. Okay, I didn't have to do show all of these things here. And that tells us that BA is congruent to AD, but it's a parallelogram. BA is congruent to CD, and AD is congruent to BC because it's a parallelogram. So all of these guys are congruent. I've got more than I need to have in that one. The second direction is if you start with a rhombus, you want to show that the diagonals bisect the opposite angles. So if these sides are all congruent, okay, what else do you know about a rhombus? Okay. You know that the diagonals are perpendicular to each other. So I know that the rhombus is a parallelogram. So I know that the diagonals bisect each other. So that gives me that they bisect each other. So by side, 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 I've got triangle A, B, E, and I should put E, E in here where it's always been. Is congruent to triangle ADE. Okay, and this is side, side, side. And that means that these angles have to be the same. So angle BAE is congruent to angle DAE. And similarly, you get these the same, so that splits that one, and vice versa. These are the same, those are the same, so on. So opposite. Angles are bisected. Okay, let's work a problem from the book now. Number 32, we want to figure out what angles 1, 2, 3, 4, and 5 are, what their measures are. I have yet to come up with a really slick way of doing this. I just basically come in and compute everything. So let's do a few of these. Let's so ABDF, that's a parallelogram. BCEF is a parallelogram. CBD is 22. Okay, I'm going to write these in a minute. AD is parallel to FE. Okay. Note that if AD is parallel to FE, and FE is parallel to BC, then AD is parallel to BC as well. Okay, let me put some numbers in here, and I'm going to type them in because a lot of these numbers we're just going to copy down a bunch of times. Okay, we need to make these about 16, and let's make them red. Okay, CBD is 22, so that goes right there. Make it 14. Okay, now, can we get anything from this? Well, CB and DG are parallel. Okay, CB and AD are parallel. I said that right here. Okay, and BD is a transversal going through here, so that means Measure of angle 3 is 22 degrees as well. So let's put that here. All right, angle E we said was 56 degrees. Let's put that in. And I should be a little more careful with some stuff. Sorry. So measure of angle 3. Let's write this down here. Measure angle 3 is 22 degrees. And it says EAF is 60. That's the big angle down here. So that is well, where do we go? What about angle 2? I have two parallelograms, BC, two parallel lines, BC and EF, and CE is a transversal coming on them. So the measure of angle 2 plus 56 degrees is going to be 180 because they're interior angles on the same side of the transversal. So the measure of angle 2 is 180 minus 56, 124 degrees. Okay, so let's type that in, write that down someplace. Now, does this show up anyplace else? Sure it does. It shows up. Okay, what do we know? We have a parallelogram BC. BCDG is a parallelogram, just like BCEF is. And when you have a parallelogram, opposite angles are congruent. Plus, those two things are 124 degrees because they are vertical angles. And as long as I'm copying a bunch of stuff down there, this is 56 degrees because this is a parallelogram here, DEFG, and opposite angles are the same, are congruent. And as I said, as long as I'm after this, that's going to be 56 degrees there because those two are vertical. I may not need all of this information, but I'm just going to put everything in here that I can. Okay. All right, what else do we have here? Okay, so I've got just 2 and 3 are the only ones. Let's take a look at angle. The measure of angle of well, I'll add here. Here's 22. There's 22 down here as well. Didn't see that volume. BD and AF are parallel. These are alternate interior angles. Okay. Now let's get angle 5. Okay. The measure of angle 5 plus 22 should add up. Oops, should add up to, well, 56, right? 56 degrees is going to be the sum of the two opposite things. So this is going to be 56 minus 22, 34 degrees. as long as I'm at it. Let me put it in up here. I don't think I'm going to need that. Okay, what is the measure of that angle? Okay. Well, that's 60 minus 22, so that's going to be 38. Right. Here. And now we can get the measure of angle 1. And I'm going to use the exterior angle theorem. 124 is an exterior angle for these two. So the measure of angle 1 plus 38 is 124 degrees. Okay. So that's going to be what, 86? Is that right? 86. Let me see. I can't. 14 and 8 and 4. So, yep. Okay. Measure 86 degrees. Goes there. And now to get angle 4, let's see, what do we want to do here? Wrong one. That's 38. Okay. So angle 4, okay, this is 38 because DF and BA are parallel and we have a transversal crossing there. Now DG and EF are parallel and DF is a transversal, so the measure of angle 4, 38 degrees. Okay, lots of stuff going on there. I think it's a good problem. Well, hope this helps you with the homework.